Oh, morning, Jomi. Okay, Chris, that's fine. Just know that this is going to be archived, so you can always watch it after the fact. But you won't be able to ask any questions, obviously. But if you have any questions, you can ask them like right now. Like if you had an issue with the homework, feel free to just drop it in the chat right now. But otherwise, that's fine. Okay, so I just put a link in the chat to our Discord server. Um, I had a technical problem yesterday in my grade 10 class. All of a sudden, YouTube decided it didn't want to stream anymore, and I lost my stream, and it was very frustrating because I didn't know what the problem was, and there wasn't really anything I could do. I tried a different computer, I tried to reboot, and just something about my YouTube account just, I don't know, probably has something to do with the fact that I've uploaded probably over 20 hours of HD footage in the past week. They probably just had some kind of ingest issue, but anyways, if we have any technical difficulties, I'd like Discord to be our backup. Some of my other classes, I've been using Discord while I'm live streaming, and it's pretty cool because if you have a microphone, you can just talk right into it, and then also the lag is much smaller. So in a second, I'm going to go live there. So it'll be exactly the same video feed. The only difference is that you would have the advantage of talking, and I'll just put a little earphone into my ear, and then I'd be able to hear your voice, and I can answer your questions right away. So I'm gonna just set that up now, and then we'll get started. We're going to talk a little more about slope today. So that's our goal for the day, is to talk a little bit about slope and how that affects our graphs, and more importantly, the equations that our graphs represent. So that's our goal for today, is just to have an investigation into slope. I know that this is something that you already have looked at in the past, but I want to look at it again, and kind of maybe maybe with fresh eyes, we can see things that maybe we didn't see before. So let me just get this set up here with Discord. How do I do that? There we are. So I'm in the grade 9 advanced audio chat. And there we go. So doesn't look, oh, it looks like we've got one person who's online in grade 9. Oh, two people. So if you want, you can just join the live stream here. Okay. Okay. Okay, let's get started then. All right. Okay, it doesn't look like anyone is going to do the Discord thing, but if you change your mind, I'm here, so I'll keep my earphone in. So on the off chance that anyone does decide they want to join, then they can do so. Yeah. Okay. So where were we? Here we go. Okay. Okay, so the first thing I want to talk about is this idea of slope. So slope is a huge topic in math, and it's not just in grade 9 that we talk about slope. We talk about slope in grade 10, grade 11, grade 12, and we even talk about slope in calculus. Calculus is, in a lot of ways, just the study of slope. That's really what calculus is. So having a deep understanding of what slope is and how to use it is really, really important. So we're going to talk a little bit about what slope means. So in its simplest form, slope is just rise over run. That's all it is. So if I were to have a graph, and I've got some kind of line on that graph. Okay, now I'm hearing myself on Discord. Oh, that's because someone else is on Discord. Okay, perfect. Okay, so if I were to have a graph like this and some kind of line like this, some kind of thing like this. Okay, what I mean by rise over run is I'm going to take 2 points on the graph, and it doesn't matter which points they are. However, it is useful to choose points that are easy to know, like what the points actually are. So like if you just chose like maybe like this point over here, well, what's your x value and your y value? So x, y is what? So that might not be the best choice of a point, but I think that this point right here is good. And I'm kind of assuming that my graph sort of follows the lines of the grid paper that my screen is showing. So this would be like 1, 2, 3, 4, 5, etc. This would be 1, 2, 3. You get the idea. So so this first point that I chose, this one over here, it looks like it's maybe like 4.2 comma, I don't know, 2.8. It looks like maybe it's that point there, but it's hard to say because it's not on the intersection of those grid lines. So I'm gonna just completely erase this point because I don't really care for it. I'm gonna stick to points that I know about. So this is a good point to choose, and then this is another good point to choose because it's also at the intersection of those grid lines. Oh, your headset is being mean to you. Okay, sorry about that. So what we're gonna do is we're gonna say, okay, well, what's the rise over run? And what I mean by that is that when I go from one point to the next, what is my rise and what is my run? So I'm gonna call this point, this first point, I'm gonna call it x1, y1. I'm gonna call this next point x2. Oops, that's supposed to be a 2. x2, y2. Okay, so in other words, the first one is just my first point. That's why there's ones. And I'll just zoom in so you can really see what I'm doing there. So I've got x1, y1, and x2, y2. And what I mean by rise over run is, so the rise is going to be the change in the y's. And this little symbol here, this triangle, that means delta. So I'll just on the side here, I'll write delta means change. Okay, that's a big term that we'll use quite a bit. Maybe not even so much in this class, but if you end up studying physics, you'll be using the word delta a fair bit. So it's a good idea to get the sense of what this word means. So we've got delta as change. So the rise is going to be the change in the y's, and the run is going to be the change in the x's, right? So rise means difference in up and down. Run means difference in left and right. So so I'm going to just say that that the slope is going to be, well, we usually represent it with the letter m. I'm not sure why we use the letter m, but we just do. So that's going to be delta y divided by delta x. That's what it means. And delta y, let's take just a peek at what delta y actually looks like. Well, the change in something, change is we can calculate change with difference, like subtraction. So I'm going to take the second one, y2 minus y1, and I'm going to take the second one here and subtract the first one. So delta y is y2 minus y1. Delta x is x2 minus x1. So in other words, m is equal to y2 minus y1 over x2 minus x1. And that's really all there is to it. So that's what slope is. So if I ever ask you to calculate slope, you need to find 2 points on the line and subtract the coordinates from each other in this very particular way. So for example, this graph, this line has slope. Well, let's calculate it. So in this case, it looks like y2, I'll just write y2 minus y1 over x2 minus x1, and let's calculate what each one of these are. So in this case, y2 is, it looks like, y2 is going to, this is x2, y2, so y2 is the y value of this point, which is 2. So I've got 2 minus, the y value of the next point, which is 1. So I've got 2 minus 1 over, and now I've got the second x value, which is right there. So that would be 3. And I've got the first x value, x1, which is there, which is also 1. So this is going to be 2 minus 1 divided by 3 minus 1, which is 1 over 2. So the slope is 1/2. And that's how we calculate slope. There's a question. Are we going to have these live streams over spring break? No, we're not going to have live streams over spring break. I am going to talk a little bit about a homework assignment. I'm not going to sort of overload you with homework over the break. I do want you to have an actual March break. But I do need to get an assignment out of you guys pretty soon. So we'll talk about that in just a minute. Okay, so I'm kind of assuming that we've already seen some stuff with slope. So I don't want to spend too much time sort of reviewing it and going over it, but I do want to talk about where slope comes in to our linear equations. So so we talked a little bit about slope-intercept form yesterday. So we were looking at slope-intercept form. And I want to talk a little bit more about the different kinds of forms that we can have with an equation. So, by the way, the reason I kind of brought this up is because we're going to use this formula in just a minute, because this is actually a very useful formula, and we can get a lot of other formulas out of it. So so let's talk about slope-intercept form. So slope-intercept form. Okay. So slope-intercept form, that's when an equation looks like this: y equals mx plus b. And I think that we've seen this quite a bit already. So here, m is the slope, and b is the y-intercept. Okay, so so we've got slope-intercept form. This is kind of like your vanilla type of linear equation. It's a linear equation because there's no exponents on the variables, and when you graph it, you get a straight line. So yeah, we're going to take a look at some of the different forms that you can have of a linear equation, and they're all kind of equivalent to each other. There's really no one that's better than the other. But in some situations, it's useful to be able to convert from one form to another. Can you just let me know in the chat if you have seen anything other than slope-intercept form? Like if you learned about like point slope form or intercept form or anything like that? General form, standard form, any of those? Okay, so you did point slope. Okay, so that's good. Okay, so we'll look at, I'll review point slope again. Okay, that's good. And then I'll take a look at intercept form as well. Okay, so let's take a look at point slope form. So let's do point slope form. Point slope form. Okay. So point slope form is it looks something like this. So I tend to forget how to write point slope form. So what I'm going to do, I want to show you the algebra behind it, and I want to show you kind of where this comes from. So so point slope form comes from the definition of slope. Okay, like the very definition. This definition right here. This is kind of what I was talking about earlier. How this formula really comes into play when we are writing about other forms of lines. So it comes from the definition of slope, and I want to show you what I mean. So the idea is that if a line has slope m, okay, so if a line has slope m and passes through a point x1, y1, okay, so just some random point, well, not random, but some arbitrary point, x1, y1, okay, so we've got one point and we know its slope. Well, think about it like this. Then the slope must be equal to, okay, the slope has got to be equal to this. Well, I'm going to say that the slope m is equal to, well, by definition, by the very definition of slope, it's equal to what was it? x2, no, y2 minus y1 over, no, not y, x2 minus x1, right? That's the very definition of what slope is, right? Now, we actually know one of these points. We know the point y1 and x1, okay? So I'm just going to actually write that nicely. I've got y1 and I've got x1, okay? What about y2 and x2? What are these? Well, by the definition of slope, it doesn't matter at all. It doesn't matter at all what the other point is. The slope is always going to be the same. So as long as it's some point other than x1 and y1, we can use any point on the line to represent that slope. So you can choose any point. So in other words, any point on the line is going to work. So let's just say it works for all of them. So let's just use the general variable x and y, because it has to work for every single line or every single point on our line. So let's just choose all of them. And this is where the formula comes from. So this is essentially point slope form. We still have just a little bit of algebra to clean up, and I want to make this look a little bit nicer. So there we go. That looks a little bit better. So now what I'm going to do is I'm going to multiply both sides of the equation by x times x minus 1. So pretty much thinking of this guy coming up here. So what I get next is something that looks like this. I've got m times x minus x1 is equal to y minus y1. And that's what point slope form is. So this is a really useful equation. And it's useful because you can graph something when you only have the slope and a single point. It doesn't have, excuse me about the hiccups, it doesn't have to be a specific point like slope-intercept form. We had like b is a very specific point. Like we had the slope, but the point that we had was the y-intercept. That was the only point that we could have used. Point slope form is much more powerful because you only need a single point on your line. It doesn't matter which point; it could be any point. So it's quite a powerful tool. Okay, so I want to cover one more. Form, and that is it's just called intercept form. It's just called intercept form. So, and I guess I've been titling these in green. Okay, so I've got intercept form. Okay, so intercept form is based on, this is based on the x and y intercepts of the line. Okay, now this only works, this form only works when the x and y intercepts are not the point 0, 0. So we cannot have x-intercepts or y-intercepts at the origin. Just reading some of your comments. What kind of assignment are we going to be getting? I'll talk about that in about 10 to 15 minutes. I want to just talk about these different forms shortly, and then we'll talk about it. So what I mean by that is Okay, so the whole idea of intercept form is that it tells you the x and y intercept. So when it's in this form, what we could do is we can say, okay, let's say that this is our, this would be our y-intercept right here, and maybe this is our x-intercept right here. And then once you have 2 points, then you can just graph those 2 points, right? All you have to do is just graph them, and then you would get your line, and you'd be done. But the problem is, if the y-intercept and the x-intercept are the same, like if it's just this point right here, well, you don't have 2 points anymore, so you can't make a line, right? Who's to say that your line is not this, or this, or this, or this, right? There's an infinite number of lines that pass through the origin. So if your x and y intercepts are both the origin being this point right here, the point 0, 0, then you're gonna have a bad time graphing it. So this form only works when your x and y intercepts are not the same. And the only way that they could be the same is if they were both the origin. Okay. All right. So I'm just going to write this one down. If you like, you can try to derive it yourself. It's really not that hard to derive. Basically, all you have to do is just solve for x and y intercepts. But the gist of it is that the form is x over a plus y over b is equal to 1. And when the equation is in this form, we get these two values a and b. A is the x-intercept, and b is the y-intercept. Okay. Okay, so those are the 3 forms that I wanted to talk about. So we have intercept form, we've got point slope form, and we have slope-intercept form. So, and I hope that we have some understanding of slope. So I'm going to take a minute just to talk about our assignment and some of the Google Classroom stuff that I invited you to last night, and some of the homework and assignments that I'd like you to work on shortly. So let me just pull up the Google Classroom, and let's see how many of you actually accepted my invite. Hold on a second. Will it be just like a worksheet? Yeah, it's just gonna be like a worksheet. Okay, grade 9 advanced. Oh, looks like we got 15 students. Yeah, so we're still waiting for a few people to accept the invite, but I think we're doing pretty well. I think I didn't invite everybody. Yeah, I did not. I forgot to invite the other. I only invited one section. I think I invited just the B section. I forgot to invite the M section. So let me get it on that right now, because I'd like everyone to be invited, of course. Emails, 2. No, I think that's, I already did that one. A1. Here we go. Copy. Oh, no, I already did this section. Okay. So I did the M section, not the B section. Okay, just give me a sec here to figure this out, and then I'll just invite everyone. Oh, brother. Okay, invite. Here we go. Awesome. Okay. Okay, so I've invited, as far as I know, oh, hold on a sec. What the heck? Okay, I'll finish this up in a second. So in any case, I've invited you guys to a Google Classroom. So I'm gonna use this just for homework while we're away from school right now. That way I can give you. Okay, Google Classroom is being a little bit weird right now. Not sure why. But let me know if you are having difficulty logging into Google Classroom. Okay. Okay, it looks like a few people were invited. So yeah, definitely. If you can't get into Google Classroom, let me know as soon as possible, and I'll make sure that you're in. If I'm noticing that you're not enrolled in it, then I'll just send an email to your folks and just make sure that you're in, because I don't want anyone to miss out on their assignments and that kind of thing. So yeah, on the Google Classroom, I'm gonna post an assignment there today. It's going to be really similar to just the stuff that we've been working on already. The due date, I really don't want to assign stuff over the March break. That said, I am going to assign an assignment today, and it's going to be due on Monday. Okay, so we'll kind of think of the weekend as being still sort of fair game, and then you can hand the assignment in on Monday, and then you'll be done. So oh yeah, what happened to that other thing where we take pictures? Okay, so I tried CrowdMark out. I tried it with my grade 10 class, and it didn't work out very well. It kind of honestly was a bit of a fail. I mean, I think it's a good program, but it just there was just such a steep learning curve for everybody that I didn't think that now was the right time. So I think that everyone has some familiarity with Google Classroom. I didn't want to have to set everyone up with a new app and a new. I know that like a lot of people are probably feeling a little overwhelmed with all this new software that they're having to figure out all at once. So I kind of just figured that, you know, you're probably already on Google Classroom with other classes, so I just thought, yeah, let's just use what we already have, which is Google Classroom. That's also why I really wanted to use YouTube instead of Zoom or some of the other programs, is because you guys already use YouTube, right? You guys are probably, like, a lot of you probably are actually YouTubers, so you kind of already are familiar with the format. You don't have to log in. Just make it as easy as possible. Okay, so that's that with CrowdMark. So if school doesn't start until September, are our exams going to be canceled? I don't know. That's a good question. It's a fair question. I wish I had the answer to that. So right now, I mean, our whole economy is sort of at a bit of a standstill because we don't really know what the future holds. And I know that's a little bit freaky, but I don't know what our exams are going to look like. I don't know if school is going to be canceled or if it's just going to continue on in a sort of a digital format like it is now, or if maybe we're going to stick to the original plan and come back the week after March break. I don't know, and I don't think anyone really knows. And a few of my students in other classes have sort of asked my opinion on this and what do I think. And each time I always say the same thing, which is that honestly, like, my opinion doesn't really count for very much in this case. So I'm not going to state what I think is going to happen. I'm not going to make any predictions because that's not my role. my role is to teach you math and not to comment on the global pandemic that we're in the middle of, because I don't have the expertise to comment on it. So yeah, does anyone have any questions about the assignment, kind of the things that I'm going to be asking on it, the format? It's going to be hopefully as self-explanatory as possible. So what I'd like us to do is like I'm basically going to have it as a Google form, and I'm going to have some like multiple choice questions that are kind of just going to be one or the other, like pretty straightforward. But I also would like to see your work, and a nice thing that Google Forms does is that it allows you to submit a photo. So excuse me. So I still haven't quite decided how I want that to work. Like I don't really want to have to mark photos. That honestly just sounds like like an awful marking experience. But yeah, so I'm gonna sort of look into different ways of marking. So stay tuned. All the information is going to be on the website. I'm going to do my very best to have it done by the end of the day, and it'll be due on Monday, because I do want to give you a solid break, because I know that you guys are probably chock full of homework right now. So yeah, and is this a test? No, it is not a test. It's an assignment. So and the assignment is going to cover basically all the stuff that we've been looking at in the past little while. So I might actually ask a couple questions about trigonometry and some circle geometry. Not like a whole lot, but just enough just to make sure you're still thinking about those things. But then for the most part, it's going to be talking about factoring, simplifying rational expressions, and I might ask a couple questions about linear equations, kind of the stuff that we're doing right now. So why don't I do a couple examples here, and then we'll call it a day. So what time is it? It's about 9:35. So yeah, we got enough time for a few examples. So so I'm going to do just a few examples. I'll try to do an example where I'll graph something in each of these forms, and then I'll see if we can try to go from one form to another. Okay, so let's see here. Come on. There we go. Okay, so example. So graph y equals 2/3 of x minus, I don't know, let's say 2. Okay, so we're going to graph this. All right. And actually I'm going to have to go a little bit further because my y-intercept is going to be -2. So notice that this is in slope-intercept form, right? So our slope here is 2/3, and our y-intercept, which we're calling b, is -2. So the way we do this is I find my y-intercept, I mark it with a point, and then I use my slope to calculate the rise over run. So to find another point, I think my rise is going to be 2, so rise is 2, my run is 3, so my rise is 2, so I go over 2, so 1, 2, and then over 3, 1, 2, 3, so my rise was 2, my run was 3, so my point is right there. So that's my next point. Once I have 2 points, I can just connect them with a straight line. So I'll get a line that looks something like this, and that's my line. And we'll extend it in both directions. We'll put an arrow on either end to signify that it's going off in both directions infinitely. There's a few more things that I want to write on my graph. So whenever we're graphing things, it's important to mark that this is our x-intercept, this is our y-intercept, and then I also like to point at the line and say this is the line y equals 2/3 of x minus 2. Okay, so that's the line. I'm also going to mark the x and y intercepts. So this is the point 0, -2, and this is the point 3, 0. Okay, so that's pretty much it. So that's our slope-intercept form. I'm also going to say, going to sort of throw this question out here because this is an important question. Write an equation that has, write an equation of a line, pardon me, write an equation of a line perpendicular to the last equation that passes through the point, let's say negative, let's do 4, -2. So 4, -2. Okay. So perpendicular lines. So really all that means is that we've looked at perpendicular before. So perpendicular just means that it makes a 90-degree angle. So we can kind of imagine our line kind of going something like this, right? So our slope is now not going to be positive, it's going to be negative because I'm going down. So negative slope means that I'm going down, a positive slope means I'm going up. So let's talk about the slope for a second. So the slope, the way we calculate the slope is it's going to be the negative reciprocal of our old slope. So this was our old slope. So basically what we do is we flip the fraction upside down. So I've got 3/2 and I make it negative now. And there's all sorts of reasons why that is, but you can kind of think of it as if it's perpendicular, then all of a sudden our rise is our run and our run is our rise, except now it's going negative. So that's really the long story short. So there's our slope. We have a point 4, -2. So now that we have the slope and we have a point, we've got enough to graph it because we could do this in point slope form. So using point slope form, we get so I'll just write what the actual equation is. It is y minus y1 is equal to m times x minus x1, and in this case, y is just y. y1 is going to be -2, and m in this case is -3/2, and then x is just x, but x1 is 4. And now let's clean this up a little bit. This is y plus 2 equals -3/2 times x minus 4. And let's graph this. Okay, so if we graph this, well, let's do that right over here. So when I'm graphing something in point slope form, we're going to have something that looks like this. So I've got my x-axis, my y-axis. So I'm going to start off with the point that I know. I know that the point 4, -2 is on the graph. So this is my point 4, -2. And I know the slope. So I know my rise over run. So my rise is going to be -3 and my run is going to be +2. So starting here, I know that my rise is -3. So -3, so I go 1, 2, 3. And my run is 2, so I go over 2. And this is my point right here. So what was that? 3? Yeah. So right here. And now I can just make a nice straight line from one point to the other, and then this is my line, like this. Okay, so there you have it. And so that's a line that we graphed using point slope form, and just by looking at it, so just like a visual comparison, you can tell that these are perpendicular to one another. Like this green line right over here and this pink line over here, they're perpendicular to each other. Like if I were to sort of copy this one over here, I'll just copy and then I'll paste it. They're perpendicular to each other. Like that makes a 90-degree angle, and that's not a coincidence. So the slope, I mean, you can kind of imagine where we would have drawn this, but the slope is absolutely at 90 degrees there. So so that's really important to be able to make a sort of a visual check. I think okay, let's do one more. So what I'm going to do is I'm going to say so graph. No, sorry. I'm going to start off by saying, so write the equation of the line whose x-intercept is, let's say, 0, 3, and y-intercept is, let's say, 7, 0. Okay? Then graph it. Okay? So using the intercept form, well, we can have, we're going to say that x over the x-intercept, which is 3, plus y over the y-intercept, which is 7, that's all equal to 1. And there's the equation. If you want, we could convert this into slope-intercept form. So let's convert this into slope-intercept form. And really all you're doing when you convert something into slope-intercept form is you what am I trying to say? When you convert something into slope-intercept form, you're just solving for y. It doesn't really matter what's on one side as long as y is all by itself. So basically all we're going to do is just use algebra to solve for y. So this is going to give me y over 7 is equal to negative x over 3 plus 1. And now I'm going to multiply both sides of the equation by 7. So I'm going to get y is equal to 7 times, and I'm going to sort of turn this into a fraction in a second. So this is going to be x over 3 plus 1. I'll use the distributive property to distribute that 7. So I get y is equal to, and now this is the fraction I'm thinking of, negative 7 over 3 times x plus 7. And I mean, that hopefully looks right. I mean, in terms of consistency, b is still b, right? Like this is still our y-intercept, right? Which is important because that's exactly what the question was saying, was that the y-intercept is 7, 0. So our y-intercept was 7. In the slope, in the intercept form, we said that this is our slope, this is our y-intercept, which is 7 right here. And then even when we turned it into slope-intercept form, it's still 7, which makes sense. Like if it wasn't 7, then it probably means that something is kind of fishy here. But it's still 7. So now let's graph this. So I'm going to graph it like this. And there's a couple ways I could graph it now. I could use either one of these forms. I'm just gonna point out that if I know the x-intercept, well, that's going to be 0, 3. Oh, I made a mistake here. Bear with me here. This doesn't make sense to be the x-intercept. The x-intercept should be 3, 0, because the y value should be 0, and the y-intercept should be 0, 7. It doesn't change any of our algebra here, but it doesn't make sense to talk about an x-intercept whose x value is 0. It's that the y value is 0. So I'm sorry about that. I hope that's not too confusing, but it doesn't change any of our algebra. I just had the coordinates mixed up. And then our y-intercept is 7, so I've got 1, 2, 3, 4, 5, 6, 7. So that's actually all the way up here. So maybe I'll just extend my my y-axis a little bit further. There we go. And so now all we have to do is just connect the dots, and it's going to look something like this, and I'll do it in green. So let's just connect these dots here like so. Okay. And there we have it. So we just had those 2 points, we connected them, and there's our line. If you wanted to, you could also graph it using the slope-intercept form. So you could have said, okay, well my y-intercept is 7, that's this point here, and my slope is -7/3, so my rise is -7, so 1, 2, 3, 4, 5, 6, 7, and my run is +3, so 1, 2, 3. You could have done that, absolutely. But since we already have these 2 points, I think that it just makes sense just to go straight to connecting the dots. Okay, so if you don't specify the form of the equation, can we give it in any form? Can I just find slope and use y-intercept to find the equation y equals mx plus b? Yeah, absolutely, unless I specify otherwise. So, so just in case you didn't read the comment, somebody asked, so if it's not specified which form to use, can we just use slope-intercept form? Yeah, absolutely. You can use any form that you want, and I think it's actually a really good exercise to be able to go back and forth between the different forms of the equation. But something to keep in mind is that if you're pressed for time, like converting like this information into slope-intercept form takes a bit of work, right? And as you do, different steps of algebra, you're opening yourself up to some errors, right? Whereas if you just point out that, hey, here's a point, here's another point, it's a line, so it's got to be straight. Well, just connect those 2 points, and then you're good, and then that's the whole line. So yeah. I guess my advice is just to do whatever is the simplest and requires the least amount of work. That's always my my recommendation in math, because the more work we do, the more opportunity for errors we introduce. So so yeah, just try to keep it as simple as possible. So yeah, I think I'm gonna leave it there. And the assignments, the assignment that I post, hopefully is self-explanatory in terms of how to submit it. If you do have any questions about submitting it, don't hesitate to reach out by email or Instagram or your favorite way to contact me. Now that we've got Discord, you can use Discord. Okay, so when we're graphing, you only need 2 points. I have a tendency to make a whole bunch. Yeah, so it's okay. So the question was, when you're graphing, do you only need 2 points? Well, it depends. The short answer is yes, you only need 2 points. The long answer is it depends. You in the context that we are in, which is linear equations. So linear equations. So these talk about lines, and lines are straight, right? Okay, so as long as you're graphing a linear equation, you only need 2 points. Like if I gave you 2 points, like these 2 random points, there is only one line that passes through both of them. And I'm not talking about a line segment or array, I'm talking about a line, right? And we know that lines are infinite in length. So there's only one line that passes through these 2 points. So for that reason, when you're graphing a linear equation, you only need 2 points. Now keep in mind, like if your 2 points are like this point and then this point right here, those are awfully close to each other. And if we zoom in, then hopefully you can see that like I could sort of like graze past this one like this. That line is going through both points. I could also make a line like this, which is also going through both those points. So what I'm trying to say is that when your points are very close together, just by the nature of like the thickness of your pencil and the fact that we're not you know, using like these infinitely small points that a point actually is. I would recommend choosing 2 points that are very far away. Okay, when I meant to find the equation, not to make the graph. Okay, so if you don't specify the form of the equation. Oh, I see. So 2 questions ago, I think I misunderstood the question. I guess the person was asking if you're given a graph and you're asked to find the equation of that graph, does it matter which form? No, it does not matter which form. I always think that the easiest form to use is point slope form, because you can just choose any point, and then once you have that point and the slope, then you're good. It's quite robust, because sometimes your y-intercept is kind of funky. Like maybe we don't always know exactly what the y-intercept is. Like if I gave you this graph right here, like this, okay, and let's say that the y-intercept was like right here, it'd be kind of hard to use slope-intercept form. However, I know, well, this point is like right on those crosshairs, right? So, and then it looks like the graph is kind of headed over here. So you could find the slope by choosing these 2 points in the crosshairs. So this would give you your m, and then you know this point exactly here. You know this point here. I'm just writing p for point. So because they're in the crosshairs. So I would recommend using point slope form if it's not specified. But if it's not specified, then it's not specified, and you can use any form that you want. Just make sure that you are being precise and that you're not just eyeballing it, right? Like don't go to me and say, oh, that looks like maybe it's like 6.5, maybe 6.6. Like no, that's not what I'm looking for. We're not looking for sort of eyeballing sort of these estimations. We're looking for precision here, so that's why it's important to find points that sort of meet at these sort of these crosshairs right here, right? So yeah, does that answer your question? I'm hoping that's a little more clear now. So yeah, I think I'm gonna sign out unless there's any more questions, and that should do it. I think that's it. So yeah, stay tuned for the assignment. I'm gonna post it on the website shortly, and I'll post it on Google Classroom as well. That way, when I'm finished marking it, I can just put your mark on Google Classroom. Oh, you guys want to see Goose? Where is she? Hold on a sec. Here she is. Okay. Say hi, Goosey. Okay, so yeah, I'm gonna, oh, she's very internet famous, absolutely. Okay, so I'm gonna sign out then, and if you have any questions, don't hesitate to reach out. As for spring break, like I said, like I'm not gonna be signing in and doing lessons and stuff like that. That said, if you do have any questions, like I'll be around, I'll be online. So yeah, like Instagram is on my phone, so anytime you message me on Instagram, I get a notification. Same with Discord. So if you send me a message on Discord, I get a notification. Same with my email. So yeah, just reach out if you have any questions about anything. I'll make the assignment available today, and then you can work on it this weekend and hand it in on Monday, and then you'll have a little break, which I think will be really nice. So I'm gonna sign out now, and do I have a Discord server? Yes. Let me paste. Oops, that's not what I wanted to paste. If you just scroll up to the top of the chat, I put a link there. I'll paste the link again. But yeah, I have a Discord server now. So Yeah, okay, so I'm gonna go, and I will talk to you in about a week. So I hope that you have a really good spring break. If I find out any information on school closures or openings or anything like that, I'll post it on my website and Discord, and I'll do my best to make sure that you hear about it. But like I said, we're not going to be doing lessons and things like that. So okay, take care. Bye bye.